Hi, this is Dr. Swapna and I welcome you to your Learn Lab. If you are an IGNOU student looking for help in your studies, then you have reached the right place. Here we have lecture videos on different core and elective subjects of important IGNOU courses. We aim to help you ace your exams. So hit subscribe to our channel, and as you watch, make sure to like and share too. Come and join me on this beautiful learning journey.
In this video, we are doing block 1, which is scientific research and empirical methods in behavioral research. Under block 1, we are doing unit 2, titled problem and hypothesis. We have already finished the problem part in our previous video, and in this video, we'll concentrate on hypothesis. So what are we going to study? We are going to study what is hypothesis. Then we'll see what are different types of hypothesis. We'll also see how to test a hypothesis. Finally, we'll see what is descriptive statistics. Let's see what is a hypothesis. Hypothesis is a statement. All right. So let's take an example. I'm saying that awards affect motivation positively. All right. So this is my hypothesis. Now see, this is a statement. Okay. It introduces the research question. So looking at this hypothesis, you can guess what I'm going to study, right? I'm going to study whether providing or giving awards are going to affect the motivation. Could be in an employee setup or could be in a school setup, right? So it introduces the research question. It also tells the result that is proposed. So this is the result that I'm proposing, and that is what is being stated in the hypothesis also, that awards affect motivation positively. All right. And also hypothesis is an important tool of scientific method that makes up the research process. All right. So this was a brief introduction to hypothesis. What? That it's a statement. It introduces the research question. It tells the result that is proposed, and it is an important tool of scientific method that makes up the research process. Coming to a more formal description of hypothesis, hypothesis refers to a tentative solution to a problem. Okay, so our problem is whether awards are going to affect motivation or not. We are providing a tentative solution in the hypothesis that awards do what? Affect motivation positively. So I'm providing a tentative solution to that problem. Okay, also hypothesis refers to assumptions made in advance before starting a research. So I'm already assuming before my research starts, the first step is hypothesis, stating a hypothesis, right? So when I'm stating a hypothesis before the research starts, I'm assuming in advance that my topic, that is uh, awards, do affect motivation positively. Okay, so this is an assumption that is made in advance before starting a research. Also, hypotheses are tested using statistics, then accepted or rejected accordingly. So we have a whole different subject which is BPCC 108, entirely dedicated to studying statistics and hypothesis, testing and proving the hypothesis using different statistical techniques. So here all you need to remember is that hypotheses are tested using statistics, then accepted or rejected accordingly. So if the hypothesis is accepted, then the results can be replicated. If the hypothesis is rejected, then the result need to be refined or modified. All right. So the whole of statistics you see is centered on accepting or rejecting a hypothesis. All right. Now the hypothesis may not always support a research. We'll see how. Okay, when we study the types of hypothesis, I'll explain this part. Why we say that hypothesis may not always support the research. All right. Now let's look at different sources of hypothesis. So the first source that we have to study is culture. Okay, the values and beliefs prevalent in a society can influence the development of hypothesis in human psychology. All right, so every society has different set of values and beliefs. If you in India itself, if you see southern part of India, the values and beliefs there would be totally different from what there is in north, or maybe in northeast, or maybe northwest also. So based on the values and beliefs which are there in the society where the researcher is also living, it can influence the development of hypothesis when it comes to human psychology. All right. Then secondly, we have personal experience of a researcher. Now, researchers own prior knowledge, means whatever the researcher already knows about a particular topic, and his or her experiences can be a fertile ground for generating hypotheses about the world around them. Okay, so we said that hypothesis is generally a tentative statement which is providing solution to a problem even before the research starts. So a personal experience of the researcher means what the researcher knows beforehand and what are their prior experiences can also be a big contributor to the generation of hypothesis. Third, we have thoughts and imaginations. The researcher's imaginative thinking, creativity, personal ideas, and reasoning abilities contribute to hypothesis formulation. So, first we have culture, we have the personal experience of a researcher, and thoughts and imaginations of a researcher. These are all sources of hypothesis. We have more of them. So, next we have scientific theory. Existing scientific theories provide a framework for understanding phenomena and can be used to generate hypotheses that test or extend these theories. Okay, so hypotheses can also be obtained from scientific theories which are already present or which already exist, and the hypothesis can be stated to either test or extend those existing theories. All right. Then fifth, we have previous research. So if someone has already done research on the topic that you have chosen, that can also help you to find out the gaps in the existing research. And based on that, you can generate a hypothesis. So reviewing existing research on a topic can reveal gaps in knowledge or inconsistencies in findings, which can inspire new hypotheses. All right. And lastly, we have observation. Now, observing patterns, relationships, or anomalies can lead to the development of hypotheses that explain the observed phenomena. So, if you just observe around, if you are a good observer, you will have lots of topics wherein you can generate different hypotheses and initiate a research work. All right. So, these are all the different sources of hypothesis. Next, let's move on to types of hypothesis. All right. So, hypotheses employed in research are of two main types. The first is null hypothesis. Second is alternative hypothesis. Let's start with null hypothesis. Null hypothesis is also called negative hypothesis or statistical hypothesis. All right. So this is a very important part of hypothesis. Stating a hypothesis. We have studied that the first step in research process is stating a hypothesis, and null hypothesis is the first hypothesis that is stated. Okay, null means zero, so it's also called zero hypothesis. All right, that should be easy for you to remember, right? Null means zero, so it's also called zero hypothesis. It's symbolized as H0. Okay, this is after zero hypothesis. It's an important decision making tool in inferential statistics. Now, what is inferential statistics? You will learn in BPCC 108. All right. So all you need to know is that the null hypothesis is an important decision making tool in inferential statistics. Now, as I said, null hypothesis is the first stated as part of a research process, and it states that there is no difference between two population means. Okay, maybe you are studying two different populations. You are checking the literacy levels in two different populations. This is just an example. So when you are stating null hypothesis states that there is no true difference between these two population means or the averages of these two populations. All right. So if there is no true difference, there is nothing there left for you to study. Right. So hypothesis is the first step. Stating hypothesis is the first step. So if the null hypothesis is accepted, which means there is no true difference between these two means, population means. So there is nothing for you to continue the research. You can stop the research right there. Right. So you don't want the null hypothesis to be accepted. Right. So any difference if found between sample means is accidental and unimportant. So null hypothesis says that even if you find any difference between two sample means, that difference is accidental or it is very unimportant, and it may be arising out of fluctuation of sampling or just by chance. All right. So null hypothesis states that there is zero relationship between variables used in the hypothesis. Okay, so we know that in our research we are studying two different variables, or what are the relationships between any two variables. So when you state null hypothesis states that there is zero relationship or no relationship between two variables in the which you are using for your study, or there is no true difference between two population means. All right. Now, null hypothesis is tested statistically. Okay, we use statistics to test the null hypothesis. In the absence of a strong evidence, null hypothesis is accepted. Okay, accepting null hypothesis means there is no significant correlation between the two variables, or there is no difference between the two populations under study, right? So, you don't want the null hypothesis to be accepted. But in the absence of strong evidence, null hypothesis is accepted. Null hypothesis is rejected only if statistically significant correlation is found between the variables. Okay, so here you are again using statistics. When you test and if you find that there is a statistically significant correlation present between the two variables, null hypothesis is rejected. When null hypothesis is rejected, you can continue with your study, right? So also, null hypothesis is always specific and it does not state vague or approximate values. As any hypothesis should be, this is a very specific statement and it will not include any vague or approximate values. All right. Here we have examples of null hypothesis. Okay, this is one of the statements that we have been using, that there is no significant relationship between awards and motivation. See, no relationship. This is null hypothesis, zero relationship, zero hypothesis. Another example is that exercise has no effect on weight loss. So here I have two variables, exercise and weight loss. It's saying there is no correlation between these two variables. All right, that was all about null hypothesis. Now let's see what is alternative hypothesis. All right. Now this is positive hypothesis. If you remember, null hypothesis was negative hypothesis, right? Alternative hypothesis is a positive hypothesis. It is also called experimental hypothesis or research hypothesis. If you remember, null hypothesis was called what? Statistical hypothesis, right? Now, alternative hypothesis is opposite to null hypothesis. We'll see how. Now, it is symbolized as H1 or HA. Okay, A stands for alternative. Alternative hypothesis states that there is a statistically significant relationship between two variables under study. All right. So null hypothesis was stating what? That there is no significant relationship between two variables under study, right? Here, alternative hypothesis states that there is a significant relationship between two variables under study. The difference, if present, between two samples are non-random and significant. What was null hypothesis stating? That difference, if present, is random or unimportant or by chance, right? Here it's exactly opposite. Alternative hypothesis states that if the difference is present between two samples, it's not random and it's significant. It is important. All right. Researchers work on the samples to prove the alternative hypothesis to be true. And researchers were working on the sample to prove that null hypothesis is false, right? So remember I said that hypothesis may not always support research. So this is the reason null hypothesis does not support the research. Okay, null hypothesis actually goes against the studies of the research. So you need null hypothesis to be rejected, or you need the null hypothesis to be rejected or to be proved false. All right. Null and alternative hypothesis are complementary to each other, which means they are entirely different but still together they form a whole. Each state that the other is wrong. We saw how, right? So null hypothesis states that there is no significant difference between two variables, but alternative hypothesis states that there is a significant difference between the two variables. So that's why we say that each states that the other is wrong. Mathematically, this can be depicted as H0, which is null hypothesis, states that mu1 or mu2. Here mu stands for population mean 1. So mean of the first population is equal to mean of the second population, which means there is no significant difference between the average of two populations. While alternative hypothesis, which is H1, states that mu1 is not equal to mu2, which means both the population averages are not equal. There is a significant difference between both the population means or averages. Now, we have the example here. There is a significant relationship between awards and motivation. This is alternative hypothesis. If we write there is no significant relationship, that becomes null hypothesis. Second one, exercise has an effect on weight loss. If I write exercise does not have any effect on weight loss, that becomes null hypothesis. All right. Alternative hypothesis is further divided into two types. First is directional hypothesis and the second is non-directional hypothesis. Let's see what is directional hypothesis. So, directional hypothesis is a hypothesis that states the presence of a significant relationship between two variables and also the nature of the relationship or the expected direction of the relationship. It has a theory backup. So directional relationship is exactly like alternative hypothesis. Why? Because it states that there is a significant relationship between two variables. In addition, it also tells the nature of relationship or the expected direction of the relationship. Now, what does this mean? Let's look at this example. So the first example says awards increase the motivation level in individuals. See, here we are giving a direction or a nature. Which way is the direction? Awards are increasing the motivation level in individuals. Similarly, exercise has a positive effect on weight loss. Here also we are giving it a direction. Which way it is? Is it positive or negative? It is positive. Are awards increasing or decreasing? It's increasing. So even if you say awards decrease the motivation level, that is also directional hypothesis. When you are giving a particular direction to any statement, it becomes directional hypothesis. All right. Non-directional hypothesis, exactly opposite of that. It states the presence of significant relationship between two variables, but does not tell about nature of the relationship. All right. So it should be easy for you to remember. One tells the direction, the other does not tell about the nature of the relationship. It does not specify the expected direction of the relationship. It is stated when there is little or no theory backup or when findings of previous studies are contradictory, where two different people would have studied about the same topic, but both of them are giving contradictory or confusing results. In such cases, you can have a non-directional hypothesis wherein as a researcher, you can work on it and find out the direction, right? So this is non-directional hypothesis. Example. Now, this is exactly same as what? Alternative hypothesis. Okay, there is a relationship between awards and motivation, but we are not specifying any particular direction. Exercise has an effect on weight loss. Again, there is a significant relationship, but we are not providing what is the nature of that relationship. All right, so that is non-directional hypothesis. Next, we have associative hypothesis. Now, what is this? It's a most common hypothesis in psychology. All right, it states that there is a definite relationship between variables that occur in a natural setting without any manipulations. Okay, so in nature, without applying any study or any condition or any manipulation, there is a definite relationship between two variables that is occurring in the natural setting, right? So what happens if one variable changes, the other will also change automatically. All right, so this happens without any intervention, without any external intervention from the researcher. All right. Now, this hypothesis does not explain cause and effect, why this is happening. Okay. Like what causes a particular effect. Associative hypothesis is not explaining that. Only that there is a definite relationship, and if one variable changes, the other will also change automatically without any external interventions. Now, example, there is a positive relationship between awards and motivation. Okay, so we know that if we provide awards, if there is an increase in awards, motivation will also increase. There is a positive association between physical activity levels and overall health. All right, this is also associative hypothesis. Okay, without any external intervention, if you are involved in physical activity, your overall health will improve. Okay, this is associative hypothesis. Now, based on the number of variables under study, hypothesis can be of following two types. First is simple hypothesis and the next is complex hypothesis. Simple hypothesis states that there is a relationship between a single independent variable and a single dependent variable. Okay, so example, there is a positive association between physical activity levels and overall health. Here, physical activity levels is the independent variable which the researcher will manipulate. Like when a researcher is studying this topic, he can, make different subjects choose different activity levels and see what is the impact on overall health. So this is the dependent variable, the effect on of the independent variable. All right. So simple hypothesis states that there is a relationship between a single independent variable and a single dependent variable. So now you can guess what is complex hypothesis, right? So it's a hypothesis that states that a relationship exists between two or more independent variables and a single dependent variable. All right. So example, there is a positive association between nutrition and physical activity levels on overall health. Here I have two independent variables, nutrition and physical activity levels, and one dependent variable, that is overall health. All right. So that was all about types of hypothesis. What are the different types of hypothesis that we have seen? Null hypothesis and alternative hypothesis. And alternative hypothesis further we divided into directional hypothesis and non-directional hypothesis. Then we saw associative hypothesis. Then based on number of variables under study, we saw simple hypothesis and complex hypothesis. Now this is a topic which you will see across multiple subjects. Okay, so make sure you understand this and remember this. All right. We said that hypothesis is statistically tested and then it is decided whether to accept or reject it. Right. So let's now see hypothesis testing. How is hypothesis tested? First of all, let's see what is hypothesis testing. Hypothesis testing is also called test of significance. Okay. It is a statistical method used to determine if there is enough evidence in a sample data to draw conclusions about a population. Okay. So we are checking if the data that has been collected about a population is significant enough, or if it has enough evidence to draw conclusions about that population. It is a tool for making statistical inferences about a population. Okay, so when using hypothesis testing, you can make statistical inferences or you can find out informations about a population. It tests assumptions and determines how likely something is within a given standard of accuracy. Okay, how much accuracy is there in the assumptions that have been drawn about a population. Okay, I am saying that in population A, there is a higher what number of working women who are highly motivated. Okay, and in population B, I am saying there are a fewer level of working women who are highly motivated. So I have drawn these assumptions, and hypothesis testing will let me know how accurate my assumptions are. All right. It provides a way to verify whether
Thank you all
the
for
results
learning
of
with
an
me.
experiment are
If you found the
valid
video
or not.
helpful, Make sure you let me know by
so
hitting
that
the
is
like button.
hypothesis testing.
Make sure
It
you share the
actually
video with your
tells
friends
us
too.
how
Subscribe to
significant or
make sure
how
that you don't miss out on
accurate
any of the new
the
videos.
results are.
You can reach me
All
by
right.
simply dropping a comment. See you
Let's
in the
now
next
look at
one.
different
Till then,
steps
happy learning.
that are involved in hypothesis testing. All right. So the first step we all know is stating of hypothesis. A null hypothesis and an alternative hypothesis is specified. Okay. Both these are mutually exclusive, which means both of them cannot exist together. If null hypothesis is true, then alternative hypothesis will be false. Both of them cannot be true, right? Similarly, both of them cannot be false. If one is false, the other will definitely be true. Okay, that's what is meant by being mutually exclusive. If the null hypothesis is true, then the alternative hypothesis will be false. Okay, so the first step is what? A null hypothesis and an alternative hypothesis is specified. So let's stick with the example. We are going to study if awards are affecting motivation. So my null hypothesis would be what? That awards do not have any effect on motivation of an individual. And my alternative hypothesis will be what? That awards have an effect on motivation of an individual. Okay, I have not specified any direction here. Simply stated. All right. The second step is the level of significance or alpha value is selected. Okay, this is alpha value. So what is alpha value? Alpha value is defined as the acceptable risk of incorrectly rejecting the null hypothesis. So we have rejected the null hypothesis. Rejecting the null hypothesis means what? We are saying that there is a significant difference between two variables or relationship between two variables. But we have incorrectly rejected this, which means it should have been accepted and that there is no significant difference between two variables, right? So what is alpha value? It is the acceptable risk. What is the percentage of risk that we can actually incorrectly reject the null hypothesis? Okay, that is alpha value. Now here, significance means probably true. Okay, it indicates that the result is free from any chance factor at the specified level of significance or alpha value. Okay, whatever the alpha value is, it's the acceptable risk, right? Within that risk, that the result is free from the chance factor. Okay, that the result is actually significant or important. All right. Generally, alpha value is set at 0.05 or 0.01. All right. 0.05 means there is a 95% confidence that the results are correct. And 0.01 means there is 99% confidence that your results are correct. All right. Now, why do we take 95% and 99% and not 100%? So now this is because uh, when we are working with human participants, it's very difficult to achieve 100% accuracy. Okay, because we are all subjective individuals. So we take a chance that there is a 1% or maybe a 5% chance that the results are due to probable chances or some error or mistake. All right, that is why we never take 100% alpha value or alpha value of 0. We always take 1% or a 5% chance that there could be an error or there could be a chance factor because of which we are getting the results that we have got. All right, 0.05 means there is a 95% confidence level that we have done it all correctly. 0.01 means there is a 99% confidence that the results are all correct. Okay, now this is a very important concept. I hope you understood it. Alpha value is how much, what is the acceptable risk, how much chance you can take that your null hypothesis has been incorrectly rejected. Okay, which means null hypothesis should have been accepted or there is no result, no significant difference, the study should not have been conducted, but you are still going ahead, right? So what is the risk of that? It's the alpha value. Significance means probably true, could be true also, it could be true. This indicates that within the acceptable risk that the result is free from any chance factor. All right, so that is level of significance. So now Whether the null hypothesis is accepted or rejected depends on whether the calculated statistical value is greater than or less than the alpha value. Okay, so when we have the data, we calculate our test statistic. And if that test statistic is greater than the alpha value, null hypothesis is rejected, which means alternative hypothesis is accepted, or there is a significant difference between the two variables under study. And if the calculated test statistic is less than the alpha value, then the null hypothesis is accepted, which means there is no significant difference between the two variables under study. All right. So remember, if the test statistic has a higher value, null hypothesis is rejected. Okay. Higher calculated value means rejection. If lower calculated value means acceptance of the null hypothesis. Now the third step, that is data collection. We have already stated the hypothesis. We have selected the alpha value. It could be 0.05 or 0.01. Next step is sample is selected randomly from the population. Okay, what does this mean? This means every single member in the population has an equal chance of getting selected into the sample which is under study. Okay, if there is a population of say 1000 individuals, random selection means any of these 1000 individuals can be selected in the sample, which could be maybe just 50. Sample size may be just 50, but any of these 1000 have equal probability to be chosen in this 50. Okay, that is meant by random selection. And once the sample is selected from the population, data is collected from this selected sample. All right. So after the data is collected, we are going to perform statistical analysis on it. We calculate the test statistic. Based on the parameter specified in the null hypothesis, the statistic is calculated. There are different kind of statistical tests which you will study in your BPCC 108 paper, such as independent t-test, chi-square test, and so on. All right. You perform all these tests and then you calculate the test statistic. The statistics obtained from the sample is then used in order to make an estimation about the population parameter. We use the statistic to also decide whether to accept or reject the null hypothesis. All right. So our first step was what? Stating the hypothesis, null hypothesis and alternative hypothesis. Then we selected the level of confidence, right? The alpha value. Then we selected the sample from the population and collected the data. After collecting the data, we have performed statistical analysis on the data and calculated the test statistic. Now using this test statistic, we are going to decide whether to accept or reject our hypothesis. Next step, we have calculation of p-value. We have calculated the test statistic, right? Next, we calculate the p-value. P-value stands for probability value. Okay, this is the probability of the null hypothesis being correct. Okay, that the probability of null hypothesis being accepted, that is p-value. Okay, and the p-value will always be between 0 and 1. The value or the number that represents the p-value will always fall between 0 and 1. Any value beyond these values less than 0 or greater than 1, you have calculated your p-value wrongly. Okay, so probability will always be between 0 and 1. All right. Now p-value indicates whether the results obtained after conducting a test are statistically significant or not. Okay, it will tell whether whatever study you have done is statistically important, significant, or correct or not. It also indicates the probability of making an error in rejecting or not rejecting a null hypothesis. Okay, so p-value will also tell you the probability whether you are accepting or rejecting the null hypothesis in a wrong way, or you are making an error in your judgment, or whether you are incorrectly accepting or rejecting a null hypothesis. Okay, this is what p-value does. It tells you the probability of whether your null hypothesis is correct or not, or whether you are by mistake rejecting or accepting a null hypothesis. And the last step is accepting or rejecting the null hypothesis. Now we have all the necessary data that we need to accept or reject the null hypothesis. Whether the null hypothesis is accepted or rejected will depend on whether the statistical value obtained after the data analysis is more or less than the table value specified at 0.05 or 0.01 level of significance. Okay, alpha value. All right. Now, tables for various statistical techniques are provided at the end of any book on statistics. Okay. If the obtained value is higher than the table value, then the null hypothesis is rejected. We have already discussed this. If the calculated statistical value is higher than the alpha value or the table value, the null hypothesis is rejected. And if the obtained value is less than the table value or the alpha value, then the null hypothesis is accepted. Okay, you need to remember this. Higher the calculated value, null hypothesis rejected. Lower the calculated value, null hypothesis is accepted, which means if the obtained value is low, this means there is no significant difference between the two variables under study. Only if the calculated value is high enough, higher than the table value, the null hypothesis is rejected, or there is any significant difference between the two variables, so you can continue with the research process. All right. So these were the 6 steps involved in hypothesis testing, and this is a very important topic. All right. Next, let's see two important types of hypothesis testing. We have two types of hypothesis testing, which is called one-tail test and two-tail test. So we look at the one-tail test now. One-tail test is also called directional test. It is very similar to directional hypothesis. And what was that? It was a hypothesis that was telling that there is a significant difference between the two variables, but it also tells the nature or direction of the hypothesis, right? So one-tail test is similar to directional hypothesis or testing of a directional hypothesis. Only one tail of the distribution is considered for the critical region or the rejection region. See, this area marked, this region is called critical region or the rejection region. Critical region or the rejection region means if your calculated test value falls within this area, then it means that the null hypothesis can be rejected. Okay, now this is all about null hypothesis that we are talking about. So if the calculated test statistic falls within this area of the distribution, then the null hypothesis is rejected. Okay, that's why this is called critical region or rejection region, and it is present only in the one single direction. Okay, so if the calculated test statistic falls within the critical region, it suggests that the observed results are unlikely to have occurred if the null hypothesis were true, or null hypothesis can be rejected. Okay, if the null hypothesis were true means what? Null hypothesis, when will be the null hypothesis true? When there is no significant difference between the two variables. So the calculated test statistic, if the calculated test statistic falls within the critical region, it means whatever results you have got will not have occurred if there was no significant difference between two variables under study. There is a significant result difference, that's why you have got a particular result. So null hypothesis can be rejected. Okay, why? If the test statistic falls in this particular region. One tail test can be further classified into two, a right tail test and a left tail test. You can see here, in one there would be a tail in the right side, that is the the region of acceptance or the critical region, sorry, not the region of acceptance, the region of rejection. The critical region or the rejection regions falls towards the right side, and in the left tail test it would be on the left side. Let's see what is a right tail test. It's also called upper tail test. Okay, it's used to check if the population parameter is greater than some value. Here, see, alternative hypothesis states that mu1 is greater than mu0 towards the right. Okay, if the test statistic has a greater value than the critical value, then the null hypothesis is rejected. So if you know number line, this is 0, this is all +1, +2, +3 value increases this side, right? And here -1, -2, -3, the values decrease towards this side, right? So the critical region falling in the right side means you were saying that your test statistic has a greater value than the critical value, right? So when the test statistic has a greater value, we know that null hypothesis is rejected, right? And if the test statistic falls in any of this area, which is less than the critical value, right? Which means your null hypothesis can be accepted. All right, so that is right tail test. Now left tail test, it's also called lower tail test, right? What was upper tail test? Here it is lower tail test. Now it's used to check whether the population parameter is less than some value. See, mu1 is less than mu0. Okay. Null hypothesis rejected if the test statistic is lower than the critical value. See here, now towards the left. Here according to number line, this is -1, -2, this your values are decreasing. And your critical value is what? Is higher than the test statistic. So what happens? Null hypothesis is rejected. Okay. Here null hypothesis rejected if the test statistic is lower than the critical value. Okay. So this is left tail test. After the one tail test, we have the two tail test. As the name suggests, it has two tails here. See, two tails. So there are two critical regions. It's also known as non-directional test. Okay, so we'll be testing non-directional hypothesis here, where we are not specifying any direction, but just saying that there is a significant difference between two variables. All right, so two-tailed tests check for a difference in either direction, towards the positive direction and towards the negative direction. It might increase or it might decrease. It might be positive or it might be negative. All right. So test where it tests whether a sample mean is significantly different from the population mean without specifying the direction of the difference. Okay. This was what? Non-directional hypothesis. The alternative hypothesis does not specify a direction. Both tails of the distribution are considered for the critical region. See, there are two critical regions here. Okay, so if our alpha was 0.05, we will have one critical region here at 0.025. Here that is minus 0.025 and plus 0.025. Okay, and if it was what 0.01, what would it be? It would be 0.005, that is by 2. Again, this is also by 2, and here also 0.005, this value, right? So this is a two-tail test or a non-directional test. All right. Now we have completed what is a hypothesis. We have studied what are the different types of hypothesis. We have seen the sources of hypothesis. We have also seen what is hypothesis testing and the different steps. We just finished different types of hypothesis where we studied one-tailed and two-tailed hypothesis. Under one-tailed, we had left-tailed and right-tailed. Now we are going to see errors in hypothesis testing. Okay, what are the different reasons of errors which can come up when we are performing a hypothesis testing? These are the simple reasons. Okay, first one, faulty sampling procedure. We said that sample should be selected randomly, which means if there is a population of 1000 people, we are choosing 50 from the 1000 in our sample, right? So every single person or every one of those 1000 should have equal probability to make it to the 50. Okay. If you are not selecting the sample randomly and you are choosing a bias or a particular condition, right? Something, maybe it's a convenience for you. Okay. In which case the sampling procedure becomes faulty. When that becomes faulty, there could be a possible error that can crop up in your hypothesis testing. All right. So always choose random sampling for your hypothesis. Secondly, inaccurate data collection method. If you are not using a proper or standardized data collection method, again, there could be an error in hypothesis testing. Faulty study design. You have collected the samples properly, you have a proper data collection method, but if the whole plan of your study is faulty, even then the hypothesis testing can give you an error. Okay. Inappropriate statistical methods. You will study about different types of statistical methods. So if you don't choose the correct statistical method for your study, even then there could be an error in your hypothesis. Lastly, incorrect conclusions drawn. So if you are drawing wrong conclusions from your result, that could also result in error of hypothesis testing. Okay, the hypothesis might be giving you a correct result, but you are taking a wrong interpretation out of it or concluding it in a wrong way. Okay, so these are the different sources of hypothesis errors in hypothesis testing: faulty sampling procedure, inaccurate data collection method, faulty study design, inappropriate statistical methods, and incorrect conclusions being drawn. Now, hypothesis errors in hypothesis can be of two main types. Okay, type 1 error and type 2 error. Okay, so what are we doing the hypothesis testing for? To determine whether to accept the null hypothesis or whether to reject the null hypothesis. Okay, based on that, the error can be type 1 or type 2. What is type 1? When a null hypothesis is that is actually true is rejected, which means a null hypothesis was actually true. There was no significant relationship between two variables, but you are rejecting it and you are saying no, there is a significant relationship between two variables and continuing the study. Now that is type 1 error, where null hypothesis that actually true is rejected. This happens when the level of significance used to reject the null hypothesis is high. If you are using a high level of significance, like we said 0.01 or 0.05, if you are using a higher level, there is a chance that you end up having a type 1 error, where you are actually rejecting a null hypothesis which is actually true. Okay, this is denoted by alpha error. This we also called as alpha error. Now, what is type 2 error? When a null hypothesis that is actually false is accepted. This means null hypothesis that is false means there is a significant difference between two means, but you are accepting the null hypothesis and taking that there is no significant difference between the two variables. Understood? So here null hypothesis was actually true. There was no significant difference, but you rejected the null hypothesis and decided to go ahead with the fact that there is a significant difference between the two variables. Here exactly opposite. The null hypothesis is actually false. Okay, null hypothesis being false means there is a significant difference between the two variables, but again you are accepting it and going ahead with the fact that there is no significant difference between the two variables. This happens when the level of significance used is stringent or very strict. Alright, so in earlier case, type 1 error, this was happening when there was a higher level of significance being used. Here there is a stricter, stringent or very strict or very limited level of significance is being used, and this is denoted by beta. Alright, that was type 1 error and type 2 error. Besides type 1 and type 2 error, we have two other types of errors also in hypothesis testing. We call it random error and constant error. Okay, now what is random error? It's an error in measurement when the observational values are inconsistent in repeated measurement of a constant attribute or quantity. When you are repeating a measurement, okay, of a constant attribute or a constant quantity, you are getting different values or inconsistent values. This is called random error because this occurs due to a chance factor. Okay, for example, you are trying to check your weight. Okay, you are checking the weight multiple times and every time the weighing machine is showing you a different value. This is called random error. All right. The next is constant error. Now, what is constant error? It's the error that occurs due to inaccuracy in either the observation or measurement process. That may be due to defective apparatus or inaccurate observation. This is not a result of chance factor. If it's a chance factor, it's not in your hands. But if it is not a chance factor, it's a mistake from the end of the researcher. Maybe the process you are using is not correct, or there is a defect in the apparatus that you are using, right? That is constant error. All right. So now we have studied 4 different types of errors in hypothesis testing. Type 1 and type 2, then constant error and what? Random error, right? So let's move forward and see what is descriptive research. Okay, we have completed our study of hypothesis and hypothesis testing, and let's see what is descriptive research. So descriptive research is a research that accurately and systematically describe the characteristics of a population, situation, or a phenomenon. All right. So descriptive research is a type of research that accurately and systematically describes, it's there in the name itself, right? Describes the characteristics of a population or a phenomenon or a situation. It presents a broader picture of the situation. Okay. Now, descriptive research can answer what, where, when, and how questions, but not why. Okay, it will tell you what is happening, where is happening, when it is happening, or how it's happening or happened. But it will not tell why it is happening or why it happened. All right. It's ideal when not much is known about the problem. So when you don't know anything about the problem, your first step is to do a descriptive research where you are describing all the attributes of the research. You are finding out what, where, when, and how about your topic that you are planning to study. All right. So once you have the descriptive research, you have a background or base on which you can build your further plans and studies. We have a few textbook definitions of descriptive research. So your study material will have quite a few of them. I have chosen a few. You can study one or two in case you are asked to write about descriptive research. It's good to have an academic definition in your paper, right? So the first definition that we have is given by Best in 1983. He defines descriptive research as it is concerned with the conditions or relationship that exist, opinions that are held, process that are going on, effects that are evident, or trends that are developing. Okay, it is primarily concerned with the present, although it often consider past events and influences as they relate to current conditions. Might be a bit difficult. You will have to mug it up. Okay, so what is Best saying? It is concerned with what? The conditions or relationships that exist. Okay, opinions that are held, or what a person thinks about something, right? Opinion that are held, processes that are going on, effects that are evident, that is would be a 5, or trends that are developing. It would be easy for you if you study it in parts. Okay, so first part would be it is concerned with what? First, the conditions or relationships that exist. Second, opinions that are held. Then processes that are going on. Then effects that are evident, or trends that are developing. Okay, next sentence. It is primarily concerned with the present. Okay, although it often consider past events and influences as they relate to current conditions. So even though they are concerned about the present, it also considers past events and influences as they relate to the present conditions. All right, that was the definition given by Best. Next we have Lowell and Lawson in 1970 stated that descriptive research refers to research which does not involve experiments. It seeks to discover the nature of the factors involved in a given situation. It seeks to determine the degree to which problem and hypothesis they exist, and it tries to discover the links or relationship between the factors. All right. So here we can break it down again. Descriptive research refers to what? Research which does not involve experiment. We are not doing any experiment in descriptive research. This happens before the actual experiment, right? When you know nothing about the problem. This is for describing the problem or getting a broader picture about the problem. Okay, so the first sentence by Lowell and Lawson says descriptive research refers to a research which does not involve the experiment. What does it do? It seeks to discover, okay, it seeks to discover what? The nature of the factors. nature of the factors. What kind of factors? That are involved in a given situation. Okay. It seeks to determine the degree. Seeks to determine what? We'll cut it here. The degree to which problem and hypothesis exist. We'll cut here. And it tries to discover the links or relationship between the factors. Tries to discover what? The links and relationship between the factors. All right. So this was the definition given by Lowell and Lawson. Next, we have the definition given by International Encyclopedia of Psychology in 1996 states, descriptive research is almost self-explanatory. It occurs when the researcher merely wants to describe an individual's or a group's behavior. There is no technicality here. It's International Encyclopedia of Psychology says that descriptive research is self-explanatory. You don't have to go into any details. It explains itself. It occurs when the researcher merely wants to describe an individual's or a group's behavior. Okay. Now, American Psychology Association, APA Dictionary of Psychology in 2015 defines it as an empirical analysis intended to test predetermined theories or sum up existing conditions and sometimes relationship without manipulating variables or trying to determine cause and effect. Okay. Empirical analysis means something that can be observed. Okay. Analysis that is conducted by observing. So empirical means observed. So it is an empirical analysis intended to test predetermined theories. Okay. Or sum up existing conditions and sometimes relationships without manipulating variables, which means no experiments, okay, only observations, and or without manipulating variables or trying to determine cause and effect. There is no why here, okay, only what, how, when, right? So this is APA Dictionary of Psychology, which is giving a definition of descriptive research. We have completed the definition of descriptive research. Now let's look at features of descriptive research, okay, features or the characteristics. And the first one we have is that it's a quantitative research. Now, what is quantitative? It means it has to do with numbers. Okay. When there are numbers involved, you can do statistical analysis also. Okay. So, quantitative research means descriptive research is a quantitative method of study that aims to gather quantifiable information and data to be used for statistical analysis of the sample. That's why we call it as a quantitative research. Secondly, descriptive research is affected by uncontrolled variables. It is the variable that has the ability to adversely affect the relationship between independent and dependent variables. This can lead to false interpretations and inadequate outcome. So the uncontrollable variables are those variables which the researcher is not actively studying, which is not a part of the study. Okay, it just crops up or maybe ignored by the researcher, but it has the ability to adversely affect the independent and dependent variables. Even though it is not the part of a planned study, this variable can adversely affect the independent and dependent variables. So this can lead to false interpretations. Okay, so let me give you an example. I am saying that see, let's take the motivation example. So I'm saying that awards increase the motivation in individuals. Okay. Now here there is something, maybe something called age is an uncontrolled variable here. Okay. It's quite possible that the awards might be affecting motivation positively in younger individuals. But when someone is an older person or maybe near their retirement age and they have seen it all and they don't care about awards and recognitions, okay, in such an individual this theory will not hold true. So here age is a variable which was not considered by the researcher but is adversely affecting the relationship between dependent and independent variable. Okay, this might be a vague example. You can think of any other example similar to this, right? So this is uncontrollable variable. Next, we have the third feature of the descriptive research, that it is a cross-sectional study. It involves cross-sectional studies. It is typically a cross-sectional study analyzing various parts that belong to the same group. Okay, the study involves samples across sections, various parts, studying various parts that belong to the same group. All right. So about descriptive research, which we can conclude that descriptive research is the relationship between variables that currently exist in the natural setting. Okay, without any manipulation. It also tests the hypothesis, establishes generalization, and results in some estimate. All right. So we are connecting descriptive research with hypothesis here. Okay. In descriptive research, we are testing hypothesis also. All right. So we are done with our second unit, and we have finished hypothesis and descriptive research. All right. Let's move on to the previous year questions. Okay. So the first question came in December 2024, which was the last TE. Write short notes on the following in about 150 words. This was a 5 marks question, and you had to write about null hypothesis. So again, you write what is null hypothesis, what are how it is denoted, and what are the examples. 5 marks, 150 words. You can easily write the story, right? Then in the same year, there was another question, same 5 marks question. Write short notes on the following in about 150 words each for one tail test and two tail test. And again, for this, you have to write what is a one tail test, what are the two types, two tail test, and if you can draw that graph that we have seen, all the 5 marks is yours. All right. Then June 2024, we have this question. Write short notes on the following in about 150 words. Errors in hypothesis testing. We have discussed type 1 error, type 2 error, random error, and constant error, right? You have to write about that. And then the second question was one-tailed and two-tailed test, right? Then December 2023, we had this question. Explain the process of identifying a research problem. Describe the sources and types of hypothesis. Now the first part is from a different video. You know which video is it, right? I believe you have watched it. And the second part is from this video. Describe the sources and types of hypothesis. We have discussed 6 different sources, right? And types of hypothesis. How many types of hypothesis? Again, 7 different types of hypothesis, right? So you have to write about that. That's a 10 marks question. Then in this June 2023, we had a part question. Write short notes on the following in about 150 words each. 5 plus 5 because there are generally 2 parts. So one part it is just 5 marks. And the question is errors in hypothesis testing. Again, we have discussed about 4 different errors. So you have to write 150 words on those 4 different types of errors. And in June 2022, we had explained the steps and errors in hypothesis testing. Okay, same thing. All right. You have to write the steps first. We discussed 6 steps, right? And then 4 errors. You have to write all of that. Then December 2021, we had described the meaning, sources, and types of hypothesis. You have to write the meaning. We have discussed sources. We have discussed 6 of them. And types. We have discussed 7 of them. Right? So this was all about the previous year questions also. In our next video, we'll continue with the unit 3.
Thank you all for learning with me. If you found the video helpful, make sure you let me know by hitting the like button. Make sure you share the video with your friends too. Subscribe to make sure that you don't miss out on any of the new videos. You can reach me by simply dropping a comment. See you in the next one. Till then, happy learning.